Okay, the Pythagorean theorem and its converse. All of you have dealt with the Pythagorean theorem before. What I'd like to reiterate on the Pythagorean theorem is that it only works in one situation. Does anybody know what that situation is? Nope. If you're going to say something, have an idea about it, please. In other words, don't just blurt something out. Well, obviously, it's good that we're doing this section because you don't know. It has nothing to do with being a good or a bad kid. It just has to do with being an uneducated kid when it comes to Pythagorean theorem. Pythagorean theorem only works for, what does that mean? Right triangles. Very important. I think sometimes in us, a squared plus b squared equals c squared, we get a little lost in that, realizing, this only works for right triangles. Now, in all books, you'll see it written a squared plus b squared equals c squared. I think just about every book I've ever seen. However, in my humble opinion, the first thing you always need to find is what? Does anybody know? Because here's the deal. The legs, it doesn't matter which leg is A and which leg is B. All that really matters is the legs are on one side of the equation, that the hypotenuse is on the other. Once you know what the hypotenuse is, what do you know what's left? The legs, because there's only three sides, right? There's two legs and one hypotenuse. So we always need to find the C, or the hypotenuse, first. And it's a simple drill. If it's a right triangle, what's drawn? Always. This little square right here, basically makes a square. Well, if it was the end of an arrow, you know what it always points at? Does anybody know? It always points at the hypotenuse. That corner will always point at your hypotenuse, which is your what? C. Now, since you found the hypotenuse, it's pretty darn easy to figure out what the legs are. This is a leg, and this has to be a leg. So you can make this A, you can make this B. So when you're writing Pythagorean's theorem, I'm of the opinion you should always write first, and later on in the section we'll do something that supports that more, that you should say first find your hypotenuse and say c squared equals 2. Well, the hypotenuse squared is equal to the sum of what? The squares of the what? Legs. So what would be on the other side? Squared plus what? Easy peasy. This only works for a right triangle. So let's do some examples. I'll make a quick drawing of a right triangle here. Nice and easy. Let's make this 5, this 12, and this x. If I ask you to find x, what are you going to have to do here? Put everything into what? What am I going to have to use? What equation? The Pythagorean theorem. What's the first thing I need to find?
The hypotenuse.
What is the hypotenuse? Well, this thing's pointing at it, isn't it? It's x. So I would say x what? Equals. Well, what goes on the other side? Well, what's left? And square it. What's left on the other side? Huh? I heard 12 squared plus what? Isn't it easy enough? Now, to solve this, what am I going to do? X squared is equal to 144 plus what? So x squared is equal to what? Now, have you found x yet? Why not? What have I found? I found what x squared is equal to, but I don't want that. I want to find what x is equal to. Now, if they ask you to find what x squared is equal to, you found it, but that's not. We're going to find x, so what do? Take the square root of both sides, because the square root of x squared is what? No, the square root of x squared is x. The square root of 169 is, now, 13. There's your answer. What about this one? What do I need to find first? What is the hypotenuse? It's pointing at it, 5. So 5 squared is equal to what? What's on my legs? X squared plus what? What's my next step? Evaluate this. What do I get here? Is equal to? Plus what? What would be my next step? X squared is equal to? I don't want to know what x squared is equal to. I want to know what x is equal to. So I take the square root of both sides. So x is equal to what? And these two have come up nice and even, have they not? It's not always going to be the case, though. You're going to have to probably simplify a radical, aren't you? What if you had one like this? They're going to do this to you, too. But they made this square root of 10, this square root of 5, and this x. What am I going to do here? What's the first thing I'm going to find? What is the hypotenuse? Nope. Square root of 10. Okay. He was right in looking at the right place. You just do have to make sure and don't forget to write that square root, okay? So square root of 10, and then what do I need to do to it? Is equal to, what goes here? X squared plus what? Square root of 5 what? Now, this looks harder, doesn't it? Because of the square root. But guess what? It's easier if you remember one thing. You guys remember when simplifying square roots? What did I tell you? That square root of x times square root of x is always what? It's x. It's square root of x squared, and the square root of x squared is x. Well, doesn't square root of 10 squared mean I'm multiplying square root of 10 times square root of 10? So what's square root of 10 times square root of 10? 10. Square root of x times square root of x is x, so square root of 10 times square root of 10 is 10. Anytime you multiply the same thing, you get that without the square root sign. X squared plus, well, what's square root of 5 squared? 5. So what would I do next? So x squared is equal to what? What do I do now? So x is what? Square root of 5. Turns out you have a 45, 45, 90 triangle here. We'll learn more about those later. Any questions? Okay, make sure you got that written down. Next thing we're going to talk about, something that'll take us a little time to do. Not a bunch, but it's going to be using. For those of you that are done writing that down, you can head your stuff saying using Pythagorean's theorem to classify triangles. Just a heading of the next thing we're going to talk about. Has everybody got this written down? Has anybody else left? Okay. And what I want you to do here is I want you to listen. I do not want you to sit here and be writing the whole time. So write this down. Don't draw the triangle or anything. I'll zoom out and let you write it after we're done. Okay. Can anyone tell me what type of triangle I just drew? Now, you're not writing this down, you're listening. This is a right triangle. What do we know is true about right triangles? Has a 90-degree angle, sure, right there. All right. We only just now got talking about it, but can you guys tell me something about that? Good night. C squared is equal to what? If it is a right triangle. It's called using Pythagorean's theorem to classify triangles. Wake up. I know you're cold.
Same thing if you say a squared plus b squared equals c squared?
Yes.
That's how I learned it, just like backwards.
I just talked about that earlier.
Yeah, I know, but,
Okay,
can't write it
so
this way.
I'm gonna write it this way every time because it's easier on this with this. Because what's always the first thing you gotta find? C, so why not write it first? Now, and it's also very good in this aspect for teaching this. It turns out Pythagorean's theorem will tell you whether you have a right triangle, stop writing, whether you have an obtuse triangle, whether you have an acute triangle. And this is how it will tell you. What I'm going to do is make the exact same triangle over here, except for I'm going to make this angle smaller. I want you to see what happens. If I remember right, I measured, and this one was 1 inch tall, A was. So let's go on this same grid line here. So I'm going to make this smaller. About like that. And this one I think is 7 marks. So 1, 2, 3, 4, 5. 7. This is still A, this is still B, this is still C. Now, obviously what happened to this angle? It's now what? Less than what? 90 degrees. Would everyone agree with that? Okay. What did we learn? Remember how when I drew the head and drew the stick man and said these are his arms? As an angle gets smaller, what gets smaller? How much the angle is what? Holding, correct? So what happened to C? I mean, it's pretty obvious. C went from basically almost just a little over 2 inches to almost as little as 1.5 inches there. And all I did is what? Made that smaller. So what it turns out is that Pythagorean's theorem will work in the same way. If c squared is less than, because it got smaller, a squared plus b squared, you can say without a doubt, without even drawing the triangle, that it is an acute triangle. Because the angle got smaller, what happened to C? It got what? And that makes sense, doesn't it? Because not, that 90-degree angle is holding C, right? Well, conversely, even though I know you probably know it, I'm going to take this time to do that over here as well, too. If I made enough room for 7. Let's see, 1, 2, 3, 4, 5, 6, 7. And now, I'm going to make this a little bit bigger. Only problem is I almost didn't give myself enough room here. So there's A, roughly the same size, and B, roughly the same size. What have I done with the angle now? I made it bigger. So since this now is greater than 90 degrees, what do you think happens to C? It got bigger. So what do you think Pythagorean theorem is going to work out? If the hypotenuse is squared is what? Bigger than a squared plus b squared, then what type of triangle do you think you have? And this is the other reason why I think it is because this is written in the book also as a squared plus b squared, talking about what it's bigger than. Well, I think this is easier to learn. Think about it. If this angle's less than 90, C gets smaller, so C is what? Less than a squared plus b squared, right? When this situation works out, and things work out just right, when C squared is equal to a squared plus b squared, you know you have a what? And as that angle gets even bigger and becomes greater than 90, which of course is an obtuse triangle, it makes C bigger, so C squared's got to be what? Bigger than a squared plus what? So what you're going to have here is problems like this. Tell whether the triangle is obtuse, right, or acute. And they're going to give you 3 numbers. They're going to say 3, 4, 5. They're going to ask you to say, is that right, acute, or whatever. We'll do 3 of them here. Then they might have one like this. 9, 6, and 3. Then they might have one like this. 8, 10, and 9. Let's figure out what type we have here for each one of these. What am I going to do here? I need to put a comma there, don't I? That looks like a 45. Okay. How do you know which one's the hypotenuse? What's it always going to be in a right triangle? The biggest of the 3, is it not? And that's a good question, because that's the one place you don't know where to start. But if you think about it, isn't C always the biggest?
Yeah.
So that's what you always make C. So the biggest here is what? So what I've got to see is how 5 squared relates to what? 3 squared plus what? 4 squared. Well, 5 squared's what? And what's 3 squared? So what you've got to figure out is basically what sign to put in between those. And what sign do you put? Equal. So as a result, what is it? It's a right triangle. Easy peasy, right? Come over here to this one. Which one's my hypotenuse? So 9 squared, I got to see how that relates to what? So I get 81. What's this? 36 plus 9. What's this? What is 81? It's what? So the hypotenuse is bigger than a squared plus b squared. So which one is it? Obtuse. Had to be obtuse because the hypotenuse is bigger. So that means that angle had to stretch out a little more, right? So it's got to be bigger than a 90-degree angle there. Last one, which one's the hypotenuse here? How does it relate to 8 squared plus 9 squared? You can probably see that already in your head. 100, how does that relate to 64 plus 81? How does 100 relate to, that's 5, 145, is that correct? How does it relate to it?
It's a cube.
It's less than, therefore making it a what? So, that answers your question even better why I like to put the c squared first, right? Because to me, it's this right here is confusing when you say a squared plus b squared has to be bigger than c squared for it to be acute. Because now bigger means what? Bigger angle, right? When c squared's bigger, it's a bigger angle. When c squared's smaller, it's a what? Smaller angle than 90, acute. When c squared's the same, it's what? 90. Make sense? But now the sign goes with the amount of that angle. Now everybody write that down. Oh, and the other thing I forgot to say, 3, 4, and 5 are called Pythagorean triples. You know why? They're 3 numbers that fit into what? Pythagorean's theorem. Wouldn't that make sense? So any numbers that fit perfectly into Pythagorean's theorem are called Pythagorean triples. Let's get that written down. Let's get to work. You have some time to work on this today. You have 25 minutes in class.